So let's start. We talked about parabolas, which was the first type of conic that we wanted to discuss. Today we want to discuss an ellipse. And you saw when we watched Khan Academy, he said it's kind of like a squished circle. But by definition of the collection of points, an ellipse is the set of all points the set of all points x, y, such that the sum, let me write my such that the sum from two distinct points and those two distinct points are called foci, plural for focus, is constant. All right, so it's a set of all points x, y in a plane such that the sum from two distinct points is a constant, and we call those two distinct points foci. Now, hopefully I can make this play again. And it takes it a second to load up. But this shows us, and I think you can see from this picture, there's just some music, so if you don't hear it, don't worry about it. It shows us how you would draw an ellipse, and I think you can see how the definition applies from those two fixed points. So let me see if I can make this bigger. So see where the toothpicks are. That would be your foci. And if you can see how to draw the ellipse, I think you can see how the sum of those from the two fixed points remains constant, because that rubber band's not changing length as it goes around, assuming it's already stretched out as far as it'll stretch. So I know that looks a little circular, but it's not quite circular, a little bit more squashed maybe. If the foci were farther apart, it would probably be a little bit flatter or more oval looking. But let's just look at it again. So you can see it again, maybe. Maybe not.
You got it. Almost there. Believe in yourself.
There it goes.
See, what did I say?
It's hard for me to stick something on the board and draw it, so I thought this would work better. So they're stretching it out, I think, about as far as they can stretch that and trying to keep it stretched. Notice those two fixed points are important in that ellipse. Okay.
So those 2 points.
Where those two toothpicks are would be what we call the foci.
Oh, okay.
The line, okay, so this is not as pretty as the ellipse that was drawn on the YouTube, but there's an ellipse, and if these are the foci, there's one, maybe two. The line that goes through the foci intersects the ellipse at the vertices. The line through the foci intersects the ellipse at the vertices.
Miss Colbert, are you going to dress up this week?
dress up every day to come to school.
No, for the days.
I doubt it.
Why not? Miss Barley was June France.
I know, she's creative. I'm not creative.
You could be Miss McKinley.
Why, I'm already a math teacher. Why would I want to be another math teacher?
Tomorrow's Old People Day.
Okay, so the line through the foci intersects the ellipse at the vertices, and it's called the major chord. The chord that joins the vertices is the major chord. And it has a length of 2a. The length of the major chord is 2a. Now, if the center of our ellipse is here, the chord that's perpendicular to the major chord through the center, the chord perpendicular to the major chord,
What is A?
we'll get to that. The chord perpendicular to the major chord through the center is the minor chord, and the length is 2b. I didn't know I hadn't turned it off. Okay, so the length of the major chord is 2a. The length of the minor chord is 2b. A is always greater than B. A is always greater than B.
This is code.
Mm-hmm.
So, which one is
The
the minor chord?
minor chord, let me change this color, would be right here.
Oh, okay.
That would be the minor chord. The length of the minor chord is 2b. The length of the major chord is 2a. And the distance from the center to one of the foci is c. Or we could say that the distance from foci to foci, from F1 to F2, is 2c. And the center's halfway in between. So this distance is c. This distance is b. And this distance is a. When we're looking at the ellipse.
Okay, you said major chord twice. Did you mean greater? Oh, wait, never mind. I see.
Okay. Now, the formula for the ellipse. We've got two different formulas for the ellipse. Remembering A is always greater than B. If we have a horizontal major axis. Let me go. All right, if we have a horizontal major axis and the center of our ellipse is HK, then our equation is going to be in the form x minus h squared over a squared plus y minus k squared over b squared equals 1.
What's the, oh, okay. Plus.
If we have a vertical major axis, then it's x minus h squared over b squared plus y minus k squared over a squared equals 1. Notice the A and the B change places. The major axis, whichever one has the major axis, has a larger number in the denominator. Because A is always greater than B. Henry?
So if A equals to B, is that a circle?
If A equals B, then you're going to have a circle. That's right.
Can you show me where A, B, and C are again?
Another way that we can find C squared is C squared equals A squared minus B squared. And of course, that depends on what kind of information we're given. Whether we need to use that or if we're given the, there's just different information you could be given. But these are the two forms for the equation of an ellipse. 2A is the length of the major axis. 2B is the length of the minor axis. 2C is the distance between the foci. So the distance from the center to one foci is C. The distance from the center to one vertex is A, or the distance to the other, it's not really a vertex, but the part that goes perpendicular through the center, the minor chord is going to be B. So that's helpful when we actually have to graph the ellipse. But let's find the standard form of an ellipse. Those are standard forms. Let's find the standard form of an ellipse having foci of negative 2, 2 and 4, 2 and major axis length of 10. That's the information we're given. We want to come up with an equation. Just like we did with the parabolas, it's sometimes helpful, or I would say always helpful, to sort of graph the information that you have. So if I know that the foci are negative 2, 2, let me make that a little bit bigger. Negative 2, 2, and 4, 2. Are we going to have a horizontal major axis or a vertical major axis?
That way.
That way, which is horizontal. Okay, so we're going to have a horizontal major axis. Now, the foci, the center is in the center of the foci. So if we want to find the center, we've got to figure out what C is. So we know that 2C is the distance between the foci. Now, the 2 doesn't change. So we can take 4 minus a negative 2, which is 6. So C equals 3. Yes?
So when we talk about the major then, is that the whole thing or?
The whole thing between the vertices.
Wait, Ms. Copa, you said that the foci are located at the foci. Oh, never mind. I see what I did wrong.
Okay, so if I'm going to find the center, I can either add 3 to the negative 2 or subtract 3 from 4, and my center is right here. So we're going to have a center at the point 1, 2. Did I move that? There. So the center is at the point 1, 2. Let me see if I can get it right back. It's one of those two. 1, 2, 3, 4. 1, 2. Okay, that's good.
Why are we using the x values instead of the y values?
You tell me.
Oh, because the y values are the same.
Because the y values are the
Are
same.
they always the same? For horizontal?
For a horizontal, yes.
Yeah.
What'd you find the center?
I figured out what C was. Then you either add it to the x value of the lower value or subtract it from the higher value. So our center point is the point 1, 2. All right, I need to know what A is. I know the length of the major axis is 2A, so A is 5. So if I start from the center point and go over 5, one vertex is here. It's 3, 4, and 1 is here. So, so A is equal to 5, we said. Can we find B?
It's 4.
How'd you get 4?
So 5 squared minus 3 squared equal to 16, and u squared root is 4.
Okay. If C squared is equal to A squared minus B squared, if I add B squared to both sides and subtract C squared, I can use this formula to find B squared. And he's right. 25 minus 9 equals 16, so B squared in this case is 16, and B is 4. So if I want to graph, from here I go up 4, from the center we can go up 4, 1, 2, 3, and we can go down 4. So now we could actually graph our ellipse. It's a little more rounded than that, but that would be the graph of the ellipse. You can't really see that pink on there, can you?
Wait, so B is the length from, like,
From the center to the edge, or not, it's not an edge, but that's your minor chord. Here's your major chord. That's your major chord. Horizontally is your major chord. Vertically is your minor chord.
how'd you find A? Is that's the length of the major chord, isn't it?
The major chord is 10, so that's 2A.
That's 5? No. Yes?
A is 5. So if we're going to come up with an equation for this ellipse, and I'm just going to have to move this out of the way. The equation for this ellipse is going to be x minus 1 squared over A squared. Where did I put H? I don't know. I just saw it when you said something. Plus y minus 2 squared over 16 equals 1. That's the equation for that ellipse.
How'd you find, is it major axis or major chord? Or does it matter?
Major chord, major axis. Probably major chord might be a little bit better, but that helps us figure out where they have vertical axis or horizontal axis too. But major chord, I'll change that, major chord. Major chord has a length of 16. Okay, so what is A?
4. Or 8.
A is 8. All right, foci are 0, 0, and 0, 8. So if I pull my graph back in, that's a focus. 1, 2, 3, 4, 5, 6, 7. And there's another one. Is this going to have a vertical axis or a horizontal axis? This one has a vertical axis. So A squared is going to go under the y. So now we got to figure out what the center is.
0, 4.
Cece? How would I get the center? Okay, so the distance between the foci is 8. So if we divide that by 2, we get 4. So what's the center point? 0, 4 is my center.
Can't you just like eyeball it?
You could here, yeah, if you have graph paper.
Okay.
But you can easily see the distance. This one's easy since it's 8. 8's the distance between the foci, so half of that's 4. All right, so that now we've got to see if we can figure out if A is 8, then my vertices are going to be 4 on the other side of this. 2, 3, 4. If I need to graph it, 2, 3, 4. There's the vertex.
Wait, what
Here's
is
my
that?
center. That's the vertices that mark the major chord.
And we know that because C equals 4.
Because A is 8. This is a foci. This is a vertice. How do I find B?
U squared minus plus.
B squared equals A squared minus C squared. So B squared is 64 minus 16.
4 square root of 3.
B squared is 48. And we would want B just to graph it. And we found out last block that 4 squared root of 3 is about 7. So from the center, I'd go over 7. 1, 2, 3, 4, 5, 6. Just almost 7. 1, 2, 5, 6. So now we could draw our ellipse, but let's go ahead and come up with our equation. It's going to be x minus 0 squared over b squared plus y minus k squared over a squared equals 1. And we could graph out our parabola, our ellipse. I think I went, it's kind of off the page. No, there it is.
When I saw the two points given for the foci.
Okay, I want to sketch the graph of this equation. I need to know the vertices, the center, and the foci. All right, now this is in quadratic form. I don't need it in quadratic form. I need it in standard form. So we're going to have to complete the square in x and in y. No complaining, please. So first thing we're going to do is group our x's together and group our y's together.
What do we do with the plus 4?
We move it to the other side.
Of course we do.
Okay, I'm going to factor out a 9 because when we complete the square, that first term needs to be...
9x.
No, because I want to complete the square. And over here I'm going to factor out a 4 because I want 1y squared, not 4y squared. Okay. Half the middle term, and we square it, and then we have to add it to both sides. But I'm not adding 4, I'm adding 36.
Point. What?
Okay, half the middle term,
Yes.
square it, and we add it to both sides. But I'm not adding 1, I'm adding
The,
36.
4.
No.
4 times 1.
Same.
So this becomes 9 times x plus 2 squared plus 4 times y minus 1 squared equals 36.
So divide everything by 36.
It's looking closer, but I need that in standard form. The ellipse is always equal to 1, so we divide everything by 36. So we have x plus 2 squared over 4 plus y minus 1 squared over 9 equals 1.
Yay.
Okay, so Nahom, is this a vertical axis or a horizontal axis?
Vertical.
Vertical axis. How did you know that?
I'm really good at guessing. I'm sorry, I've been doing line work.
Oh, that's probably not a good idea.
Yeah.
How did he know that was the vertical axis, Caden?
Because you gave us that equation, x minus 8 squared over b squared plus y minus k squared over b squared.
How did, over, both of them over b squared?
Or a squared.
So how did you know which one was a and which one was b?
Because you told me.
On this one?
I'm not the best at answering this one. Okay, on this one.
A is 9 because it's bigger.
9, okay. The 9 is a squared because it's bigger, so that tells us that we have a vertical axis. And Nahum was a good guesser. Vertical axis.
Okay. Let's go with Ken's bond. I have a long question.
Okay, so we found the center, we found A, B, and C. So we're going to graph it. We said we have a vertical axis. Our center is at -2, 1. If A is 3, I'm going to go up 3. I'm going to go down 3 from the center. If B is 2, I'm going to go over 2 and over 2. So there's your ellipse. Now if we've got to name the foci, we know the -2 is going to stay the same because we're going up and down. So we're going to have 1 plus the square root of 5 and 1 minus the square root of 5 is our foci. That's everything named and the graph of the ellipse.
All right. I wasn't comfortable about natural timing.
Okay, so here is our equation. Group your x's together, group your y's together, and the constant goes on the other side. So 4x squared minus 8x plus y squared plus 4y equals 8. Now here I have to factor out a 4 because I can't complete the square if I have a 4x squared. But over here we're okay. Okay, so we take half the middle term and square it and add it to both sides. But I'm not adding 1, I'm adding 4 times 1. Here I take half the middle term and square it, and this time I'm just adding 4 because there's nothing in front. So this becomes a 16. We get 4 times x minus 1 squared plus y plus 2 squared equals 16. Divide by 16. And we have x minus 1 squared over 4 plus y plus 2 squared over 16 equals 1. Okay, vertical, horizontal axis. Vertical. Okay, what's the center?
Is the vertical you said?
1, -2. And so if we kind of sketch that, what is A? A is not 4. Well, oh wait, you're right. I was thinking 2A. A is 4. B is
16.
2.
What?
This is B squared.
Oh.
So how do we get C? Okay, so C squared is 16 minus 4. So C is 2 square roots of 3. So if we want to name the vertices from this point, you said we had a vertical axis from the point 1, -2. We go up 4. So we have a vertex of 1, 2. And we go down 4. And we have a vertex of 1, -2 minus 4 is -6. B is 2, so we go over 2 and over 2. So now we've got enough, we can graph our ellipse. It's easier to do if you have graph paper. There's your ellipse. And if I want to name the foci,
1, -2 plus or minus 2 square root.
okay, the 1 stays the same. And then we have -2 plus 2 square roots of 3. And 1, -2 minus 2 square roots of 3 for the foci.
How do you find the foci?